Hello, my name is Kyle Carter, and I'll be discussing read-only memory, Lab 6, and here we go. Read-only memory is the storage technology that permanently stores the data in a chip built that is chip built into the computers and other electronic devices. The read-only memory usually includes some of the most basic programming that is needed to start a computer. That is usually referred to as the input and the output system. To update your read-only memory, you need to perform a flash of the ROM, which means that it is critical that the power is not interpreted, or else the computer in which the read-only memory sits may no longer function. Once it is flashed, the read-only memory is permanent and is non-volatile. And that means that it also holds its memory even when the power source is no longer there. In other words, random access memory is volatile and it loses the data when a source is removed. And it holds the program and software instructions to boot up your computer. Some of the advantages of read-only memory are that it is cheaper and it's less volatile and it's non-volatile compared to random access memory. And the circuits are simple, making read-only memory more reliable than random access memory. And the data can be stored permanently. Read-only, some of the disadvantages consist of the fact that read-only memory is read-only, so changes involves it. In order to change it, you have to go through the process of flashing, and the read-only memory chip that involves a whole new set of instructions for the circuit board, and as well as your program all together. So in regards to this lab, as a result, I was able to understand how read-only memory, how the circuit works and how it works the whole functionality of how it works all together. With the 2 inputs and the 7 outputs that was used to represent, the 2 inputs were utilized as switches to change the address value of the read-only memory, and the 7-segment display was used to show the 7 outputs. The lab made read-only memory contain four different outputs, and the outputs being a 4, 3, a 7, and a 2. The data findings showed that the lab was made of, as well as the fact that everything was built up and it worked as we intended it would. The findings implied that you have a total of 2 inputs and the 7 outputs for the 7-segment display. By turning on the 2 switches from 0, 0 to 1, 1 on the 7-segment display, you can display 4 separate outputs, and the experiment went off as we intended. So when you have 0, 0, as you can see, none of them are turned on. You get an output of a 4. When I have 0, 1, I'm sorry, I get an output of a 3. When I have, 0, 1, you get an output of a 3. When I have the output of 1, 0, I get the output of a 2. I don't know why it looks like a 5, but it's a 2. And then when I have it looks like a 5 because it's backwards, but it's a 2. And when I have them both turned on as 1, 1, I get the output of a 7. Thank you.